So, in the last class, what did we do? Dia and Eva, keep your video on. Yes, sir.
We have been doing the 1 by 2 plus 1 by 2 fraction plus.
Okay. Let's see what Sami wants to add. Adding and subtracting fractions. And why I'm saying adding and subtracting fraction? Because adding and subtracting is the same thing. Learnika. Okay? So we have been doing adding and subtracting fractions. Is there anybody in the class that has any doubt about how to add and subtract fractions? Sure. Everybody super confident?
Yes, sir.
Anika super confident? Dia super confident? Yes, dear.
I'm kind of getting confused about subtracting fractions.
Okay. So that's what I'm here for. I'm here to make sure that every child in the class has zero doubt and 200% confidence when it comes to dealing with fractions. What I will do is, so for Dia, okay, if you know how to add fractions, subtracting fractions should not be anything different from it. So what I will do is, I will put this. Let's say I want to subtract 1 by 4 from 1 by 3. Or let's say I want to subtract 1 by 4 from 2 by 3. Okay? So let's make sure, let's see how you guys are doing it. I want to see how you guys are doing it, who is getting confused, what is going wrong, and then I will do it. So I will stay quiet for next only 2 minutes because I cannot keep quiet for long. Yes, Anika, what did you get?
I got 5/12.
5/12, okay. Let's see what everybody else gets. Dia, you also give it a try. Even if you think you're getting confused, it's fine. Let's get confused, let's go around, we'll fix it. Yes, Eva, what did you get?
I got 5/12.
Okay. How about Pani?
I got 5/12 too.
Okay. Let's see what Athar, Sanvi and Dia gets. Yeah, Athar, go ahead.
We know how to subtract and add fractions, but that's no good.
Okay. So I'm going to be quiet for another 1 more minute. One second. I came for throwing the trash. So let's see what's up we got.
I got 5/12.
Okay. So Dia, how about you, beta? Are you totally stuck or you're working on it? Dia, keep your video on, beta. Yes, sir.
I got 5/12.
5 into 12 or 5 by 12? 5 by 12, okay. Dia.
I can't answer. I'm outside.
Okay. Mr. Niket. Okay.
Yes.
I I was just greeting you because you joined just now. So right now, Aniket, what we are doing is we checked what we had learned so far, or what did we learn in the last class, and everybody said that we learned how to do fraction, addition and subtraction. I was asking if there is anybody in the class who has any doubt about fraction, addition, subtraction. What I heard from one of you, and that was that I have a little bit of confusion about subtraction. So I just gave one problem for everybody to try so that we will see how do we do it. So I have got answer from many of you saying answer is 5/12. And what I'm going to do is I'm going to solve this problem and see if this is the right answer or not. Okay? So Aniket, you will not get time for solving this problem, but when I give the next one, you will certainly have an opportunity. Now, 2/3 minus 1/4. So first thing we are checking is, am I subtracting one fraction from other fraction? Yes, both are fractions. So we are good. We are talking about apples and apples, oranges and oranges, grapes and grapes, peaches and peaches. We are not talking about apples and watermelons. Okay? Same thing, same type of number, so we are fine. First thing what we do, like we do for fraction addition, same thing. We look at the denominators, 3 and 4, find out the LCM for that, 3 and 4. Let's find out the LCM. Start with the smallest number. We'll start with the number 2. 3 doesn't come in the table of 2, so 3 remains 3. 4 comes in the table of 2, that is 2 times 2 is 4, so I'm writing 2 here. Now the next number, next smallest number, which is bigger than 1 that we can go for, is again 2. 3 doesn't come in the table of 2, 3, 2, 1 are 2, done. Now we have 1 here and a 3 here, so we can go for 3. 3 1s are 3, 1 is already 1. We have got all ones, so this is what is going to define my LCM. 2 into 2 into 3. 2 into 2 is 4, 4 times 3 is 12. So we got our LCM as 12. Now this guy is done. We don't need to worry about it. Let's clean it up. So we got 12 as the LCM, which we have put here. So we took this number, looked at the denominator, found out the LCM for that, which is 12. Now start with the first number. How many times of 3 gives me 12? 4. Multiply that with what we have in the numerator, 2. First number is done. What do I have here? A minus. I am putting a minus. Then I am going to deal with the second number. How many times of 4 gives me 12? 4 times 3 is 12. Multiply that with the numerator, which is what? What did we get? 4. So 12 is 12. 4 times 2 is 8. Minus 3 times 1 is 3. So 8 minus 3 is 5 divided by 12. This is what everybody got. So you guys got it right. I also did not make a mistake. Yep. Now I will keep repeating it. I'll keep boring you guys. I'll keep annoying you guys by saying the same thing. And that is, if I'm adding or subtracting a fraction, my calculation doesn't change. It is all the same. It's the same method, same approach, same technique, same steps. And that is what I will show in one problem, which I will do. You don't have to worry about it. You guys can just see it to confirm the understanding. And then I will give you guys problems, okay? So if anybody is getting excited to solve it, don't solve it. I'm just showing it for everybody to mentally accept this, okay? So if I am saying multiply 1 by 3, add 1 by 3 and 2 by 7, subtract 5 by 7 from that. I have addition and I have subtraction. And everything works the same way. So nothing will change for me. What I will do, check. This is a fraction? Yes. Is this a fraction? Yes. This is also a fraction? Yes. No problem. All are fractions. So look at the denominator 3, 7 and 7. 3, 7 and 7. Let's find out the LCM for the denominators. Start with the smallest number 3 here. 3 1 are 3. 7 doesn't come in the table of 3. 7 also doesn't come in the table of 3. Next number I can go for is 7. 1 remains 1. 7 1 are 7. 7 1 are 7. All done. What is my LCM? 3 into 7. 21. So I am saying 21 here. Now start with the first number. We have addition and subtraction. Everything was the same way, nothing changing for us. Start from here. 3 here. 3 in the denominator for the first number. How many times of 3 will give me 21? 7. What is the numerator? 1. Multiply with the numerator. Plus, how many times 7 will give me 21? 7. 3s are 21. Multiply that with the numerator, which is 2. Then a minus. How many times of 7 will give me 21? Again a 3. What do we have the numerator? 5. All done. So, what do we have now here? 21 here. 7 times 1 is 7. Plus 3 times 2 is 6. Minus 3 times 5 is 15. What it became? 21 remains 21. 7 plus 6 is 13. Minus 15. 13 minus 15. 13 minus 15. That gives me a minus 2. Done. So what I was trying to confirm was, if I am doing fraction addition or subtraction in one problem, if I have 2 additions, 3 subtractions, whatever it be, I will only look at 2 things. One is, are these all fractions? Yes. Wonderful. If not, we will convert them to fraction. And if everything is fraction, don't have to convert. Look at the denominators, find out the LCM, and then do the same thing. Is everybody clear about it? Yeah? Pani, Sanvi,
Yes.
Aniket, Anika, Eva, Dia, everybody okay? Now, so Dia, are you okay now? Well, that was a question for Dia. Dia okay with her?
Yeah, okay.
Yeah. How about Aniket, okay? I will not let you guys be okay. So here's the thing. I'll give one more problem and then we'll go on to fraction, addition, multiplication, division. Okay? So now here's the problem. I'm putting a twist. 3 plus 1 by 2 minus 2 by 5. Be little careful while you are doing it. As long as you are careful, you will not go wrong. So do it carefully. This is a problem for you guys to solve. If anybody is having any difficulty in seeing it, now you should be able to see it better. If you are still not able to see it better, see a doctor. Eye doctor. Okay. Everybody can see the question? Okay. Do it. I was getting tempted to go to fraction, multiplication, division, but after this problem, I'll teach you guys one other technique. Yes, Anika? 31 over 30. Okay. We will see. But Anika, just review your answer by once, okay? 31 over 30. Okay. We'll see. Okay. Just anybody who completes the question, just review it once so that I don't get an opportunity to prove any of you wrong. Aniket, you also do it, okay? Everybody has to do it. Yes, you are. 31 over 10. Anika?
I changed my answer to 31 over 10.
Okay. 31 over 10. Okay. So, I know Anika was not happy with me, right? When I said not review the answer. And again, this is not specific for Anika. This is a habit that we are building for ourselves. Just to appreciate the fact that anything that we solve, it makes us more perfect when we review our work. And I'm still not saying whether 31 over 10 is right or not. I'm just saying that this is a habit that we have to get into. I forgot to pick my water. I'll be back in 10 seconds. Okay? You guys do it and then we'll talk. Okay? What did everybody get?
I got 31 over 10.
31 over 10. How about Sandri? Aniket?
I got 3 and 1/6.
3 and 1/6. Okay, we'll see. Make sure that you are reviewing your work as well, Aniket. Whatever we did, that's a habit that I'm asking everybody to get into. How about a third and the third? What?
So,
Pardon me?
one fraction 2 minus 2, 5. I got 1/10 as the answer.
Say it one more time. A third. Say it one more time, Beta. Say it one more time. I could not hear you.
Oh, okay. So 1/2 and 2/5. I tried that. And then when I did that, I got 1 and 10. So I did it with a 3 and then I got 4/10.
Okay. Now, Dia, you are not able to do it, Beta. You are outside, you said. Okay. Now, see me do this problem. And after this, I will teach you guys something that I call as dirty technique or dirty trick. Okay, so here, before I try solving this problem, let's observe this. I have a 3 here, I have a fraction here, I have a fraction here. 3, fraction. Oh, this is a natural number. Can I convert this also to fraction? Let's first do that. Now everything is fraction. 3/1, 1/2, minus 2/5. Everything is fraction. What we will do? Look at all the denominators and find out the LCM. 1, 2, and 5. So I thought same thing for you. Okay, what I was saying was, always try to convert everything to one form. If this is fraction form and this was only 3, I converted that to fraction. So now I have all fractions. So look at the denominator 1, 2 and 5, trying to find out the LCM. We know that for 1 we don't do anything. So the smallest number I will get is 2. 1 remains 1, 2 1s are 2, and 5 doesn't come in the table of 2. Next number I will pick up will be 5. 1 remains 1, 1 remains 1, 5 1s are 5. All done. Now I have all ones, so I will multiply these two numbers and that will be my LCM. 2 times 5, 10 is my LCM. Wonderful. So my LCM is 10. So I will say this is equal to 10 here, which is my LCM. Now let's go to every number one by one. How many times of 1 will give me 10? Of course 10. 1 times 10 is 10. Multiply that with the numerator, which is 3. First number is done. What do I have here? Plus. Okay. Then we go to this number. How many times of 2 will give me 10? 2 times 5 will give me a 10. Multiply that with the numerator, which is 1. Then I have a minus sign. Come to this number. How many times of 5 will give me a 10? Of course 2. Multiply that with the numerator, which is 2. Now, what is that I have here? 10. Then 10 times 3 is 30. Then I have a plus sign here. 5 times 1 is 5. Then I have a minus sign here. 2 times 2 is 4. So what I have here? 30 plus 5 is 35, minus 1, minus 4 is 31. 31 over 10. This is the answer that we are supposed to get. Now you will say, this is improper fraction. You want to convert that to mixed number. You will say, okay, fine. I can say 10 here. 10 times 3 is 30 plus 1. So you can write this fraction in this form also. That's it. Yeah. How do you get this number? You will say 31 by 10. 31 divided by 10. 10 times 3 is 30 and 1. So this becomes your numerator, this becomes your denominator, and this becomes the number here. Yeah? Everybody okay? Aniket, Athar, Dia, Pani, everybody okay? Now let me, yeah. Yes, Dia, say something better. Okay. Oh, yes, sir. Saying something? Okay. Dia is saying something, but that was not Dia. Dia for sure. I heard something coming from that. That's okay. Now, before I go to fraction multiplication division, let me show you guys one dirty technique. If I have 1 by 3 plus 6 by 3, if I have to add them, see my denominators are same. If my denominators are same, I can just write here 3, because 3 and 3, look at this, 3 and 3, what will the LCM for that? I'll go for 3, 3 1 is 3, 3 1 is 3, done. My LCM is 3. So if I have same denominator, I don't have to do this. I can put the same 3 here and then add the two things, 1 plus 6. Why so? Because 3 1 is 3 and then whatever we have, 1 into 1 is 1. Or let me do it the way we have learned. Okay? So if I have same denominators, I don't have to find out the LCM. I will just put that number as LCM. Okay. Now let's pick up this number. 3 1 is 3 into numerator, which is 1, plus again 3 1 is 3 multiplied with the numerator. What you are seeing? This becomes 1 into 1 is 1 plus 6. If you look at it carefully, all that I am doing here is called waste of time. If I have the same denominators, I can literally skip this step and go straight here. That if I have same denominator, I'll put that as a denominator and add these two numbers. Does it sound okay? Look at this. If I have the same denominator, if I find out the LCM for 3 and 3, what is my LCM? My LCM is also 3. And then, when you found the LCM, what you are doing is, how many times of this will give me 3? Obviously 1. Multiply with the numerator. Plus, how many times this will give 3? Obviously 1. Multiply with the numerator. So what is happening here is, you can choose to ignore this step and jump from here to here direct. Same denominator, you put it here and you are just adding the numerator. Is it looking okay? Now, what this means is, if I have 2 by 5 plus 3 by 5 minus 6 by 5 plus 7 by 5, I have all denominators. I don't have to do all the LCM thing now. If my denominators are same, I will just say same denominator and put these numbers. 2 plus 3 minus 6 plus 7. Without doing LCM, because my denominators are same, I can just put these things here and my calculation would be 2 plus 3 5 plus 7 12 minus 6 by 5. That is the answer. Okay, so if my denominators are same, my calculation is faster. And this concept I am calling as a dirty technique. Why? Because now look at it. If I am trying to add 1 by 3 plus 2 by 5, okay? If I am trying to add this, can we make the denominator same so that my calculation is better? So this is 3, this is 5. I'll multiply this guy with 5 and multiply this guy with 3. So this will become 15 and this will also become 15. If I am multiplying by 5 here, I have to multiply by 5 here also. If I am multiplying by 3 here, I have to multiply by 3 here also. So this became 1 to 5 by 15 plus 2 times 3 is 6 by 15. So my question was 1 by 3 plus 2 by 5. What we did was, we tried to make the denominator same. So multiply this guy with 5 and this guy with 3. And when I am multiplying by 5 here and 3 by here, I have to multiply by 5 here and 3 here. Otherwise, I am changing the value. So basically by doing this, we mad the denominator. Now 1 by 3 and 2 by 5 became this. Now we have same denominator. So I will say 15, 5 plus 6, which is 11 by 15. So why I am saying dirty technique? Because without finding out LCM, we got the answer faster. Now you will see me, if I have, let's say, 7 by 3 plus 8 by 9 to be done, what I will do is, I will multiply this guy with 9 and this guy with 3. So if I am multiplying by 3 here, to multiply with, multiply by 9 here, multiply with 9 here, multiply with 3 here, multiply with 3 here. So this becomes 7 times 9 63 by 27 and this becomes 8 3 or 24 by 27. Same denominator, 27 here, 63 plus 24. 63 plus 24 is 87. Without doing LCM also, I am able to find out the answer. That is why I am calling it a dirty technique. Okay? If this sounds difficult, ignore it. Don't worry about it. You already know how to find out LCM, how to add or subtract fractions. Yeah? Maybe we'll come back to this after a few months, okay? When you guys are a little more comfortable. Let's not worry about it. It's a dirty technique, dirty things you can forget. Okay? This will help you guys more when you get into a situation where you are doing more complex calculations and you're trying to save some time. And it can wait, don't worry about it. I deleted it. So, fraction, addition, subtraction, zero problem. Is that okay? Is that okay to say now? Aniket, Anika, Eva, a third? Salvi, Dia? Okay. So, let me quickly check if recording is still working or not, because my recording stops in between. Now I will teach you guys fraction, multiplication and division. And there is one big problem that some of you know. I am very good at fraction multiplication, but I don't know how to do fraction division. Yeah? So a third must be thinking that okay, I got stuck with a teacher who doesn't know much. Okay? And that's okay. I'll find out a solution for that. What I'm saying is, I'm very good at fraction multiplication. What I mean by that is, I'm actually talking on your behalf. I'm saying that we are very good at fraction multiplication. We love doing fraction multiplication. And you will see, because it's not a math, it's a fun activity. Now let's see this. If I say 1 by 3 into 12 by 4. I am trying to multiply this fraction with this fraction. Okay? I am multiplying. So, this is a two-story building, first floor, second floor. This is also a two-story building, first floor, second floor. And why I am saying so? Because if I have to multiply this with, let's say 21, this is a two-story building, this is a one-story building. It doesn't look easy to me, okay? So I'm trying to make everything same and then try doing it. So this was my problem. Both are fractions and both are two-story building next to each other. What I will do is, all the things on the first floor goes together. All the things on the second floor goes together. Right now what I did, I looked at, okay, is this a fraction? Yes. Is this a fraction? Yes. Both are fraction. We are comfortable. Then we say, okay, everything on the denominator goes together. Everything on the numerator goes together. Put it here. Now I am trying to start the game. 1 is a very small number. I am not touching it. 12. 12 I can write as 3 into 4, isn't it? Yeah? 3 is here and 4 is here. What I did, I found a big number, I split that into two small numbers, that's it. Which is called factorizing a number. I converted this, I have written this as a multiplication of two numbers. Now look at it. I have same 3 and 3 here, both the floors. Tic-tac-toe. I have 4 and 4 here. I can knock them off. Tic-tac-toe. What is my answer? 1. 1 by 3 into 12 by 4 became 1. Why? Because we did not multiply. We did not do any calculation. We just played with it. Now, this was just an example to begin with. Now you will see how much fun I am having when I am doing a bigger calculation. Meaning, now let's say somebody says, multiply this fraction with 25 by 9 times 21 by 8 times 17 by, let's say, 7. 4 fractions. But let's not stress out. Is this a fraction? Yes. 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 All are fractions or two-story building. What I will do first is everything on the first floor goes together. So 5 into 9 into 8 into 7. Here 4 into 25 into 21 into 17. Okay. Now let's try breaking the bigger number into smaller numbers. 5, 9 I can write as 3 into 3. 8 I can write as 2 into 4, let's say. 7 I cannot break, I will write as 7. 4, let's say I will keep as 4 because I already see a 4 here. Okay. Now 25 I can write as 5 into 5. 21 I can write as 7 into 3. 17 I cannot break, let it be. And there is no rule, there is no compulsion, there is no force that you have to break in a certain way. Whatever comes to your mind, break it, and then we'll see if you have more opportunity for breaking it. Now let's play. I see a 7 here and a 7 here, tic-tac-toe. A 4 here and a 4 here, tic-tac-toe. A 3 here and a 3 here, tic-tac-toe. A 5 here and a 5 here, tic-tac-toe. Now what do we have? We are left with a 5 here and 17 here. Divided by 3 into 2. 3 into 2 or 6. Are we going to break it further? No, we are not going to play further. So let's do it. 17 times 5 is 85 by 6. Done. So the monster that we were seeing here became a very cute kitten. Yeah, Pane's kitten. Pane keeps saying meow. So this is Pane's kitten now. Yeah. But Joseph, what did we do? What is happening, Eva? Don't do that. Okay. So here, if you look at a situation like this, be it a multiplication of 2 fractions, multiplication of 4 fractions, multiplication of 10 fractions, all that boils down to the game we do here. Check if everything is fraction, everything on the second floor together, everything on the first floor together, and then wherever you have big number, you can write in the smaller factor form, and then just play with it and you're done. So now what I will do is, I will give you guys 2 problems and I will do something to get you mad. Okay? See, Eva is already mad. Funny, I was talking about you when you were not there. So what I was saying was, the problem that we saw when we were trying to multiply 4-5 fractions, that was looking like a monster. And after we played with that, it became a cute kitten. Pane's kitten. Yeah? Alright. So now let's see how you guys are making a lion into a puppy. Let's see. So let's say I have 2 by 9 into 18 by 7 into 2 by 15 into 6 by 4. This is one problem. Second problem is 5 by 3 into 21 by 25 into 30 by 4. So this is one lion, this is another tiger. Look at some fun ways to convert these dangerous looking animals into cute puppies or calf or whatever, whichever baby animal you like. Okay, do it. And then as I said, when Eva was getting super mad, I was saying that I will get you guys mad also. So I want to do 3 1/4 into 8 by 26 into 5 by 9. So I don't know why my into is looking so horrible. Again. Okay, so this problem is for everybody to get mad. I will just read the question, okay, in case anybody is having difficulty reading it. 2/9 times 18/7 into 2/15 into 6/4. That is the first problem which you have to solve and simplify it. Second one is 5/3 into 21/25 into 30/4. And third problem is 3 1/4 times 8/26 times 5/9. And let's see how much you are playing with this, because it has to be a playful event. Aniket, you have learned a lot of tables. This is your opportunity to exploit tables, okay? Yeah. See, I am very smart. What I'm doing is I'm solving one problem and I'm dumping 3 problems on you guys. Yeah. See, that is how the teachers are lazy. No, I'm just kidding. What I'm saying is, you guys saw me do a couple of problems. I want you guys to try to problems as well. Sanvi, are you able to see the question better? Okay. Everybody can see the question? And you guys don't want to see me for next 2 minutes? Solve it. Okay. Yes, Aniket. Unmute and talk to me. Which one? Here? Say it one more time. This one, problem number 1, problem number 2, problem number 3. Here? Which question you? Which I don't know which number you're talking about. I am not able to see it. You try solving whichever way you remember, and then when I solve it, then you can relate to it. Okay? Because I am not able to follow it. Let's see what Anika got. I'll come to a third.
I got for the first one 4 over 35.
4 over 35.
For the second one, I got 42 over 4.
42 over 4.
And for the third one, I got 5 over 9.
5 over 9. Okay. Just review your answer beta while your friends are doing it. Let me go to a third. Yes, a third.
For the first one, I got 24 by 19.
How much?
24 by 19.
Okay.
24.
24 by 19. Okay. 24 by 19, is it?
Yes.
Okay. How about this guy?
For the second one, I got 42 by 4.
42 by 4. Okay. How about the third one?
For the third one, I got 5
5 by 9.
9.
Okay. Same answer as this one. Let's see what Sanvi got.
So for the first one, I got 4 by 35.
4 by 35. This one. Okay. How about the second one? 42 by 4. Okay. How about this one? Third one? Okay. Okay. Let's go to Pani.
For the first one, I got 4 over 35.
Okay, 3 kids have got same answer. How about this one?
For the second one, I got 42 over 4.
Okay. How about the last one?
The last one, I got 5 over 9.
Okay. See, when I'm putting a tick mark here, I'm not saying that this is the right answer. I'm just counting how many kids got that answer. Okay. Let's go to Eva.
The first one, I got 5 over 35.
Okay.
For the second one, I got 42 over 4.
Okay.
And for the third one, I got 5 over 9.
Okay. Let's go to Dia.
For the first one, I got 4 by 35. And for the second one, I got 42 over 7.
Okay. 42 over 7.
Yeah.
Okay.
And for the last one, I got 5 over 9.
Okay. Okay. So now, before I go to Aniket was asking me some questions that I was not able to understand because I was not able to see his notebook well. But before I go here, for this problem, most of you got 4 over 35, only one of you got 24 over 90. For the second one, most of you got 42 over 4, one of you got 42 over 7. And third one, all of you got 5 over 9. I don't need to get influenced by you guys. What I mean by that is, I will also solve this problem in a simple, easy way, and then I would know what the answer is, and you guys can also verify your answer based on what I'm doing. So this side of the board I will use for solving the problems. Let's look at the first problem. 2 over 9 times 18 over 7 times 2 over 15 times 6 over 4. This is a fraction, this is a fraction, this is a fraction, this is a fraction. Okay. All are fractions, meaning all are two-story building. What happens is everything on the first floor goes together. 9 into 7 into 15 into 4. And everything on the second floor goes together. So 2 into 18 into 2 into 6. Okay. Now, if you guys look at it, let's break this guys here. What will happen here is, now we are going to break the numbers. I have a 2, 2 is a small number, let's not worry about it. 18 I can write as 9 into 2. 2 is a small number, let's not worry about it. 6 I can write as maybe 3 into 2. And there is a safe technique. Once you have done everything, you can just multiply with 1, okay? Just putting one extra 1 doesn't hurt. Keep it. Now, 9. I will not break 9 because I already have a 9 here, okay? So, I will write 9 as is. 7 also I cannot break. 15 I can break into 3 into 5. And then 4 I can break into 2 into 2. Time to play. 1 9 and 1 9 tic-tac-toe. 1 2 and 1 2 here tic-tac-toe. Another 2 and 2 here tic-tac-toe. 1 3 and 1 3 tic-tac-toe. So here I have 2 and 2, which becomes 2 times 2 is 4, divided by 7 times 5, 35. 2 into 2 is 4, divided by 7 times 5, 35. Is this matching with everybody's answer? I deleted the answers. How much was the answer that you guys got? Eva, can you read the answer now? First one? 4 by 35. That's what you got also, Anika? Same thing, right? Okay. So, for Anika, what did I do? Nothing. I just checked. Are these all fractions? Yes. Fraction meaning two-story building. First floor, second floor, first floor, second floor, first floor, second floor, first floor, second floor. And then all the things on the second floor together. All the things on the first floor together. Yeah? And then when we have these numbers, all the bigger numbers we try factorizing them or try breaking them. So 18 became 9 times 2, 2 is a small number, 6 became 3 times 2, 9 we did not break it, we could have broken it but there was no need because I had a 9 here, we knew that we can do tic-tac-toe. 7 we could not break it, 15 became 5 times 3, 4 became 2 times 2 and then after that we just played. Now, this is what I got. Now, does this answer matter to me? No, it doesn't matter. I always keep saying this, that I don't care about the answer. What matters to me is that how are we approaching the problem? Are we clear about what we are doing? As long as we are clear, answer will come right as a byproduct. Now, let's look at the second problem. 5 by 3 into 21 by 5. Okay, one of you, everybody gave the same answer, right? What was the answer? I think everybody got 42 over 4, right? Was that the answer for the second one? Yeah? Okay, I'm just noting it down so that I don't struggle to recall. Okay, 5 over 3 into 25, 21 over 25 into 30 over 4. This is a fraction, this is also a fraction, this is also a fraction. Meaning, this is a two-story building, this is also a two-story building, this is also a two-story building. So, nothing changes for us. 5 by 3. So what 5 by 3 into 21 by 25 into 30 by 4. Let's bring all the buildings here. So what we will do is put all the things on the first floor together. 3 into 25 into 4. And everything on the second floor, 5 into 21 into 30. Now let's try breaking these bigger numbers. 3 is a small number, let's not worry about it. 25 I can break into 5 into 5. 4 also I can break into 2 into 2. This 5 cannot break it. 21 I can break into 7 into 3. 30 I can break into 6 into 5. And let me put a 1 here. I'm just putting a 1 in the numerator, okay? And we'll just start putting 1 by default. Now let's see. 1 5 and 1 5 tic-tac-toe. 1 3 and 1 3 tic-tac-toe. Another 5 tic-tac-toe. Okay. See now, what do we have? What we are left with now? 7 into 6 into 1 divided by 2 into 2, which is 2 into 2. Now, see, tic-tac-toe, this is not something that you have to do only once. If you see that you can break it further, you can break it further. So, you will say, look at 6. 6 you can break into 2 times 3, right? So, 7 I cannot break. 6 is 2 times 3. 1. And then you have a 2 into 2. So, 1, 2 and 1 more 2 tic-tac-toe. What do we have now? 7 times 3 times 1. 7 times 3 21 times 1 is 21 over 2. I'm not saying that you guys got a wrong answer. You guys got the right answer. You just did not simplify it further. See, look at this one. This is what you guys gave me. 42 over 4. 42 is nothing but 21 times 2. Okay? Same thing. 7 times 6 is 42. That's what you got. What I did, I just did one more step because I saw that okay, I have a 6 which I can break further. So, tic-tac-toe doesn't tell you any mandatory approach. It says, okay, whatever you can break it once, do your calculation. If you find more opportunity to break further, you can keep on breaking till you think that you got the smallest number. Okay? And again, remember this. I'm not saying that this is the wrong answer. This is a perfect answer. There's nothing wrong with this. I'm just saying that this had an opportunity for simplifying it further. That's it. Yeah? So this answer is correct. It's not incorrect. I just went one more step further. Okay? You can see that this is an even number. This is even number. That means there is a 2 somewhere. Okay? Alright. Is everybody clear? Aniket, are you clear?
Yes, sir.
Okay. How about Aniket? Aniket, I'm asking you specifically because you were saying something and I was trying to make sure that I'm not misguiding you. Clear? Okay. Okay. So, what did we do then?